Welcome back to part 3 on graphing polar equations. Let's sketch the graph of the polar equation r equals 3 cosine of 2 theta by sketching it in rectangular coordinates. I know that 3 cosine of 2 theta is a trigonometric function with amplitude 3, and it has a period that is double a normal period of cosine. So between 0 and pi, I will have a normal cosine, full cosine period. And it will look something like this. So there's one period of cosine, but I have to double it because of the 2 theta. So there's my sketch of 3 cosine 2 theta. You can see that it starts high at 3, it crosses at pi over 4, that's the equilibrium point. It decreases to a minimum at -3 when my angle is pi over 2. Then it increases and crosses at 3 pi over 4 at equilibrium. Continues to increase all the way up to 3 when I get to an angle of pi. And then this repeats again. I need to figure out how I'm going to use that information to graph the polar equation on my polar coordinate system. First, I know that when I have an angle of 0, I'm at 3 4 units out. I'm going to double these so it's easier to see what I'm doing. So every 2 circles, I'm going to make a dot for steps. 1, 2, 3, 4, 5. And now I'm going to sketch this as best I can. I'm starting here, and as my angle crosses through to pi over 4, which is right here, I'm getting smaller. And then between pi over 4 and pi over 2, all my radiuses are going to be negative. They're down here. And they're getting bigger negative, which means they're going to be down here. All right, so I'm going to highlight this. The first curve that I made is based on this part of my graph here. The next part of my curve I made is based off the corresponding Cartesian in green highlight that I just made. Then I'm going to decrease again as I get closer and closer to 3 pi over 4. So I need to find 3 pi over 4, and since it's negative, it's corresponding to this region over here. So that'll be this curve here. Now my radius is positive, so I'm going to work on increasing all the way up to 3, and that's between 3 pi over 4 and pi. So I'm going to identify where 3 pi over 4 is and pi. This is an increasing portion, so it increases to 3. And then it decreases to 0 on the interval from pi to 5 pi over 4. And so I'm just highlighting that in the corresponding color. Now, I hope you're starting to see the pattern that's emerging where I now curve up because I'm now in the negative region. So on the interval from 5 pi over 4 to 7 pi over 4, we're negative. So we go up to 3 and then back down again. I'm going to make that color a strange shade of yellow here. And that corresponds to this part here, this petal. And then the last little bit is when it comes back to where we started. If you wanted to graph this, again, you'd have to make sure your window's the right size and then make steps that are good choices to see as much of this petal shape as possible. You also need to make sure that your period is from 0 to 2 pi. Let's go to the y equals. Let's enter 3 cosine of 2 theta. And we'll clear the second equation here. We'll go to window, and we'll make our period from 0 as theta min to 2 pi as my theta max. My theta step I'll leave at 0.01 so you can see it plot nice and slowly, but we do need to change our x mins and our x maxes. Let's make our x min be negative 3.5 and our x max be 3.5. Let's make our y min be negative 3.5 and our y max be 3.5, and then let's graph it. And you can see how it's tracing exactly how the order was that I sketched it on the polar axes. It's pretty cool.